Hey guys, so this is a quick review. I'm going to do one for each of the segments for this test. So I'll do linear and quadratic stuff today. I'll post the one for similar triangles tomorrow and one for Pythagoras as well. So linear and quadratic was the first thing we did, where basically I gave you a table and asked you to make me a graph and tell me what it basically was. So the first thing you're going to do is look for the pattern. The way you find that is subtract the y values. So subtract the 11 from the 8, well that's 3, 8 from 5, that's also 3, and they're all minus 3. So that tells you something right off the bat, that it's a linear graph, okay? So if the first difference, basically what it means is, first difference is a fancy math word for the first time you look at the difference in the y. So if the first difference is the same, that means you're going to get a straight line and your slope is going to be minus 3. You don't need to do any more work to get your slope. You know that because that's the pattern. So to find the graph, again, all you do is just plug in the points. So x is minus 2, y is 11, put in my first point. X is minus 1, y is 8, put in my second point. Then get all your points, make a straight line, there's your graph. All right? To find the equation, remember the equation of a line is y equals mx plus b. What does that mean? Well, in this case, the slope is your m, so you put the slope, this minus 3 in instead of the x. Your y-intercept, look at your graph, where does it hit the y-axis? Well, that's at 5, plus 5, so my y would be plus 5. So my equation for this would be minus 3x plus 5. Now, the biggest mistake you're going to make is forgetting to put that minus 3 in. If it's minus 3, you've got to put the minus in as well. If your y-intercept was below the line, you'd have to put that in as a negative as well. But why do we do it? Well, we do it because then we can solve things. We can find different values that we don't have points for. That's why we give you the equation. So there's only two ways I can do this, okay? And if you know how to do it, it's going to be the same both times. All I can do is literally change this number, and I can change this number. I can't change anything else about the steps the way you do it. So if you want to know a y and I tell you an x, write out the equation, plug in the number, the value I give you for the x, run it through a calculator, get an answer for y. That's literally it. So if I was x 54, you'd put 54 in. If x was 72, you'd put, if x was minus 130 million, you'd put minus 132 million in. Run it through your calculator, get it, whatever it gives you, that's the right answer. The hard one is, if I give you the y, and I want you to find what x would give me that y. It's the same trick, but you just have to do one more step. Write out the equation, plug in the numbers, then you want to get the x by itself. So what you're going to do is flip the sign on the y-intercept and move it to the other side. Math, we tend to say, subtract 5 from both sides. But that tends to get kind of confusing when you move. You lose track of, what am I doing with it? So the easiest thing is just flip the sign, put it on the other side, and then just do what it says. Minus 25 minus 5 is minus 30. Then I've got that 3x. What I do is I divide by whatever's in front of the x, the minus 3, to divide by your slope, and you get x is 10. This will always work, okay? Flip the sign on the y, move it over, add or subtract it based on what it looks like now. Then divide by whatever's in front of the x, and you'll get your answer. That'll work 100% of the time. Quadratics. Now, for a quadratic, the way you're going to tell is, when you start doing your first difference, you're going to notice that it's not the same. So as soon as you see that, you know it's not linear, okay? As soon as you get one value that's not the same as the others, unless you've made a mistake, it's going to be quadratic. Then what you do is find the difference in your differences. That's the fancy math word for a second difference, all right? It literally just means you look at the difference again. And I'll give you a hint, in this class, it's always going to be the same because we don't do anything other than parabolas really with quadratics right now. So it'll be the same. If it's not, if this isn't the same and this isn't the same, chances are you've made a mistake because that's all I'm going to give you on a test. All right? Either this line is going to be the same or this line is going to be the same. Linear or quadratic. If the second one is different, You know it's quadratic. Again, plug the values in. -2, 4, -1, -2. Make your graph, and that's the graph part. From the graph, you can tell all sorts of things. You can find where your vertex is, -4. You can find the axis of symmetry. It's along your y-axis. You can find your y-intercept. In this case, it's also at y = 0. You can find your zeros. That's where your x hits. And then for every point, you know will be exactly the same. If it's 2 here, the corresponding point will be 2. If this one is 3, I know there will be another point corresponding it up there. Then we get you the equation. So when you use a quadratic equation, again, for the equation for that one is y = 2x² - 4. Again, same idea. Write out the equation, plug in the number I gave you, square the number, either by hitting square or multiplying it by itself. Multiply it by whatever's in front, add or subtract whatever is left, and get an answer. Now, of course, the question you're going to ask is, wait a minute, Mr. Cudmore, how do I actually know that that's the equation? Well, we're going to cheat. Well, we're not going to really cheat. We're going to use a tool. And the tool we're going to use is Desmos. Now, I'm going to show you how to do this because on a test, you're always going to have a computer in this class. That's the advantage now of us doing it online is I have to assume that you're going to be using the technology. So I'm going to design the test assuming you're using the technology. So it's desmos.com, desmos.com. Click on the add item, pick table. I've already done it just to save us some time. I put the x and y values in from our equation. All right, just copy the x and y's. To get the graph, here's what you're going to do. Click on the show keyboard, just because you may not have the same keyboard I do, so it's easier to show it to you like this. Then you're going to put in the following. And remember, you can always go back and watch this video as you're doing the test. I can't stop you, so do it, cheat. Y, 1. I'm sorry, you have to use 1. You can't just put, for x and y, you're going to have to put a 1, otherwise it gets cranky. Don't put equals. Put this squiggle, because that tells it we're going to try and figure out what it is. So y1, then we're going to put standard form for a quadratic, which is ax, don't forget the 1 again, squared plus bx1 plus c. And now that gives us our equation. It tells you what your a and your c are and your b. So we know our b is 0, so that term's going to vanish. So we know our equation is y equals 2x squared minus, because there's a -4, 4. You'll notice if you don't put that -4 in, the graph is higher, right? That's at 0. It's got a 0. The -4 brings the whole thing down, and it matches. So if you write the equation in, the new one should match the one that your table gave you. And that's how we know we got an equation, okay? So that's the skills for the beginning part. What I'd like you to do, try the couple of questions on the practice. If you're not getting it, please, please, please email me. Let me know. My goal is to basically, like right now, I'm not caring what people's grades are. I'm trying to get you as good a grade as you can. We're going to work together, okay? This is not a great situation. We really don't want it to be a case where I want everyone to get this credit. So please email me anytime. I'll answer it as soon as I see them. I can arrange, we can arrange for chats and other things like this to help. All right? Good luck. Bye-bye.